Okay, last time we saw that when I took a balloon and I rubbed it on my hair, we could see some effects from that. Like it would attract some objects, right? So sometimes things would want to stick to that balloon, or that balloon will want to stick to something else. So I thought this time I'd try something different. So here I'm going to take a metal coffee cup and rub that on my hair. And so will that work the same way? No. No effect. Why is that? Well, for one reason, the metal coffee cup is an electrical conductor. It will allow electricity to pass through it. So let's assume that even if this did get some electrons from my hair, what would happen to those extra electrons? Well, they would just come right around and come right back into my hand and be grounded. So it wouldn't end up with any charge even if it got charge on it, because those extra electrons would just pass right through it. But the balloon is not a conductor, it's an insulator. So since it's an insulator, when we get those extra electrons, if they could get to my hand, they would just flow right through my body, come back up to my hair probably. But they're stuck here. An insulator doesn't let electric charge pass through it very easily. So this one ends up having that electric charge stuck there. So we're going to take a look at another little thing here. So I have here what's called a Wimshurst generator, and this Wimshurst generator will charge up, and one side will get to be positive and one side will get to be negative. So I'd like to see here. So again, if I rub this balloon on my hair, that should make it have a negative charge. And then if this thing sticks to it, I rub it around on this. Now this should have a negative charge. So that should make it so it wants to get pulled toward the positive and it wants to get repelled by the negative. Okay, and we see that somewhat here. But now I want you to see what's going to happen if we let this actually touch here, the one that it wants to touch. So it gets attracted, and then what? Oh, now it's repelling. Huh. But it looks like it's being attracted to the other side. Oh, and then now it's repelling. And, interesting. And if I just leave it here, it keeps going back and forth like a ping pong ball between these two sides. What could explain that? Why does it keep going back and forth and back and forth? Well, what's going to happen here? So this thing, it starts out negative and then it touches the positive side. As soon as it touches that positive, what happens to it? Some of that positive charge that was there goes into this object, and then it has a positive charge as well. Now it has lots of positive charge, and it's going to get attracted toward the negative charge. And so then it will go back and forth between the two. So every time it touches one, it gets that charge. And this could be a simple motor, as a matter of fact. You can make a simple motor this way that has a positive side and a negative side, and something that goes back and forth, transferring charge. Could I do this all day long? Would this ever run out of energy? Well, sure. If you saw a moment ago, I turned the crank and that got it energized, but then every time the pith ball goes back and forth, it's transferring some of its charge from one side to the other. So the positive side keeps getting less and less positive. The negative side keeps getting less and less negative because those extra electrons on the negative side keep getting transferred over here to the positive side. Eventually, it's not going to go back and forth anymore. Okay. So we've seen some examples here of some ways that you can get something that doesn't have a charge to having a charge, right? What was one of those ways? Well, like the balloon, right? I rub the balloon on my hair at first, my hair has no charge, and the balloon has no charge. But once I rub them together, for some reason, and scientists really don't understand why, but we can know that the balloon is going to get a certain amount negative and my hair is going to get that same amount positive. There are actually tables you can look at and find things that are on either side of that table. Okay? For example, glass. If I rub the glass on my shirt here, that's going to charge this glass with a positive charge. So this one would have a positive charge, and rubbing rubber on hair would give a negative charge. So we can charge things in different ways. Okay? So friction is one way to charge something. And then the second way of charging something, we saw a few examples of this, is if you touch something to something else. Contact is the second way. So if it touches together, that's how I can charge something. Then a third way is going to be by putting something close to it and inducing a charge in it. We'll take a look at those right here. All right, in order to preserve the hair that I have and not make myself go prematurely bald, I'm going to use somebody else's hair and a rubber rod here. I'll rub these together and we're going to see. Here I've got a little thing. It has a metal top to it and it has two veins at the bottom. One of them's fixed and one of them is kind of like tin foil. It can bend. So I'm going to see what's going to happen if I put this on and I give this thing a charge. So I rub my rubber rod on here and we'll see what happens. So what's happening there? Why is it that those are going apart? Well, if we think about it, what did I do? I put extra negative electrons in here. Now, where are those extra negative electrons? Well, this is a piece of metal. All this is metal, and it's all connected. So those negative charges are going to spread out to all parts of it. And so here, when I put that negative charge on, all the parts are negative, and they're going to repel each other, right? Okay, there's a couple other things we can see about this. Another thing is, if I take this and just move it close, I put it close, and we see it moving further away. I don't even touch it. Okay. Now, if I neutralize it again, there's another thing I could do to charge this where I'm not directly charging it by contact. I could put this negatively charged rod nearby and touch the top with my finger, and when I pull the rod away, I'll see that it goes apart. Okay? When I put the rod nearby again, it comes together. Okay? This is inducing a charge. So when I put this negatively charged rod near the top here, where's all the negative charge going to go? Down to the bottom. It's going to get as far away from that rod as it can. The positive charge is going to come up to the top. So we got lots of extra negative electrons down at the bottom. And so when I touch the top with my finger, then that gets rid of that charge there. I can also use my glass rod here. I could charge that on my shirt, and we'll see if I put more positive up here, then it's going to have an effect down there as well. And we see it has the opposite effect from the rubber rod. three ways that we can charge an object. We can charge it by friction, rubbing them together. We can charge it by contact, touching them together, or we can charge it by inducing a charge. Okay? And then one thing that's related to that is, what if I have a neutral surface but an insulator? Well, if I charge something up, like my balloon again, let's see what happens here. So I charge it up, I stick it on here, and what happens? It sticks. So, what's happening here? Well, here we put the negatively charged balloon on that neutral surface, but since it's an insulator, the charges inside of this neutral ball can't move around very well. So the positive charges can get a little bit closer. They're attracted by the balloon. The negative charges are repelled a little bit, so they get pushed back just a little bit. So there's a slight charge because those negative charges inside the wood are further back. The positive charges are pulled forward, and it gives a little bit of a charge to that surface. So that's one other way that we can see electricity at work here. Okay? So the last thing, we've been talking about force as we've gone. We see the effects of force. Obviously, we have some force here. So electric force is a thing. Electric force is very important. Almost all the forces we see in our everyday life end up being electric forces. Electric force is going to depend on two things. One is how much charge is there, and the second thing is how close together, what's the distance between those charges. So the closer you are, the stronger the force is, whether it's an attractive force or a repulsion force. And then also the amount of charge you have. The more charge you have, the stronger that force will be. We'll be continuing to look at electricity and see a few more things about this, but those were the things I wanted to show you today. If you have questions, please let me know, and you can ask those questions anytime. And hopefully we can get to know just a little bit more about electricity as we go. All right.